All right, Calculus 30, section 8.1. This is largely a review for exponential functions. We've talked about exponential functions in pre-calc 30. So exponential functions are functions where we do have y and x, obviously, but x is in the exponent position of a function. Okay, so not frozen, good, all right. So this is an exponential function right here, f of x, or y equals b to the power of x. B is just some base. So if you have, like in the diagram here, this is y equals 2 to the power of x. And that's pretty typical exponential function that you've seen in pre-calculus. And so the x values of 1, 2, 3, and so on, if we were to make a table of values, x, y, then if x was -1, then this would be 2 to the -1, or 1 over 2. So at -1, we have 1/2. And at 0, 2 to the power of 0 is just 1. And so you'll see that in all exponential functions where it's just a base and an x, then 0, 1 is an intercept, okay, no matter what the base is. So you could have 3 to the power of x, you could have 2 to the power of x, you could have 1/2 to the power of x. This is always going to be a y-intercept. And if we kept going, obviously, to 2, let's say, then that's 2 squared, which is 4. And so 1, 2, and this is all the way up here to 4. So that's how the exponential function is built. It's not linear. It's not like a parabola, right? As x approaches -infinity, then y approaches what? What's the limit as x approaches -infinity of this function here? Yeah, 0. Because see how it gets closer and closer to 0? It approaches a horizontal asymptote of 0. The limit as x approaches positive infinity of this is what? As x gets larger and larger? Yeah, positive infinity. That's right. It gets larger and larger. Okay? So this is a good model for any kind of exponential growth. They call it exponential growth because it's modeled by an exponential function. All right, so what happens if the base is between 0 and 1? Well, then it flips over, right? You have your xy table, and if x is -1, well, then we have 1/3 to the -1, which flips that around to 3. And so -1 goes up to 3 here. All right, so that's how that works. So if you have a base that's between 0 and 1, it flips around. Okay, it's basically a rotation around the x or the y-axis there. Stop me if you see anything you think you've never seen before, if you want clarification on something, because I'm going to go pretty quick just through the basic, what the graphs look like and this behavior. So this is also in your textbook, Red Stewart Calculus, chapter 8, 8.1. And this has just a whole bunch of options, let's say. So here's our y equals 2 to the power of x, which we just saw right here. And if the base increases, so we have y equals 3 to the power of x, then what happens is the y values increase quicker, and they would go down to 0 a little bit quicker. So you can imagine 2 squared is 4. So 2 squared is 4. 3 squared is 9. So you have 2, 4 versus 2, 9. So it just increases more sharply as this base gets larger. So here's 2, here's 3, here's 5, here's 10, right? It rises very, very sharply. And then y equals 1 to the power of x, okay? So when the base is 1, it's a horizontal, it's a linear function. It's not really technically, well, I don't know if it's technically both or technically neither, an exponential function or a linear function, but 1 to the power of x is the same as y equals 1, right? No matter what power you take 1 to, it's always just 1. So that's a bit of an exception. Typically, the b value is greater than, is not equal to 1 when we're talking about exponential functions, because it doesn't behave like an exponential function that way. All right, so here's just a little comment on the limits. We talked about this already. For any kind of exponential function where the base is greater than 1, we don't have a fractional base or whatever, it's not negative, then what happens is as x approaches -infinity, the limit is 0. X approaches positive infinity, the limit is infinity. And again, going through this just real quick, you've seen all this before. If the base is between 0 and 1, then as I mentioned, it's kind of a reflection about the y-axis. Then we have this flipped around, still 0, 1 as an intercept, but as x approaches positive infinity, then this exponential function approaches 0. So something like exponential decay would be something like this. It would decay fairly fast in the beginning and then start to level off a little bit. So like radioactive decay or half-life, something like that, right? If you have a certain amount of time where half of a mass of something decays into other things, that's that would be half-life, then there's half of it remaining. So the time is still the same, but you're decreasing by less mass. So if you think back to physics or your science classes. So if you have 10 kilograms, it takes, let's say, 10 years, okay, to go to 5 kilograms. Well, now 5 kilograms is what you have, and if you restart the clock, it takes 10 years for 2.5 kilograms to decay, and then you restart the clock, it takes 10 years for 1.25 kilograms to decay. And so you see how it kind of like big decay, littler decay, and so it kind of like starts to level out, and half of 0.01 grams take 10 years to get rid of 0.005 grams, so it changes very little. That's an example of where you'd see that. Okay, transformations. So pre-cal 30, we spent a lot of time throughout most of the course talking about transformations of different graphs. So, and we also talked about this. So if you have a y equals 2 to the power of x graph, like in black here, and then we were to add 3 to it outside of the 2 to the x there, then literally we would take this 2 to the x graph and move it up 3 units. Okay? If it was negative 3, then it would go down 3 units and drop beneath the x-axis. The other thing that is not on this graph, I don't think it's on the next graph either. This might be the last graph I have posted right now. So the other, let's do this in yellow, but if we had y equals 2 to the power of x minus 1, okay, so if we altered or transformed this in here, then everything would move over 1 unit. All points would move over 1 unit, and so we would have a translation in the positive 1 direction. So it would look something like this, and it would transfer 1 unit over. It would mirror it like that, something like that. Okay, and then if this was plus, it would go the other way, and so on. What about? I want you to think about this. What about this graph right here? Okay, what happens to that graph? What would that look like? Take a moment. Think about that. And I will bring out some graphing calculators if you want to come on up and actually graph that on a graphing calculator. You can take a moment to grab a graphing calculator. Okay, so many of you are having a little bit of problem trying to graph this. We see that I've got a couple things lit up here. We see that the red graph on this on Desmos here, y equals 2 to the power of x, is a solid line like we've described. I've also graphed. This is still frozen. Sorry. There we go. I've also graphed the negative 2 to the power of x, and we don't see anything. And some of you said dots. Okay, well, if you think about it, it's a little tough to see on this because, again, individual points are infinitesimally small. So we have a bit of a problem when we try and plot points that are separate from other points. We can usually see them when they're put together in a line, but so if you think about a table of values here, right, then what you would find is that x, so if we have xy, and our y is negative 2 to the power of x, then if I take negative 1, what do I get? I get negative 1/2. If I take, now let's say I take 0, I get 1. What about 2? So now 2 gives me positive 4. 3 gives me negative 8, doesn't it? So you see that I'm not doing every. I guess I'll slip the 1 in there. But what happens is the values flip-flop from negative to positive to negative to positive. So if we were to graph some of these, it would sort of look like this. 0 would be positive 1. But they would be like this, okay? They would be flipping back and forth. And then if you took like, negative 0.79, okay? What's negative 2? Let's see that. Negative 2 to the power of negative 0.79. Okay, negative 0.57. If you change this a little bit, you see that it's going to be flipping from positive to negative, and it's not going to be continuous. That's the thing. It's not going to be continuous. So it doesn't really show up on graphs when you try to graph it. So a negative base for an exponential function is not able to be graphed. It's not a continuous function. So this is going to be where we have just positive bases. And again, if you check this on Desmos, try and graph it, doesn't show up. Real quickly, here's y equals 2x again. I'll zoom back out to the power of x. If we talk about, and I talked about this already, if we have subtracting, oh, come on now. Right here. So if you have 2 to the power of x minus h, and you kind of move this back and forth, it slides left, right. So that's that one. B to the power of x. So what happens? You have 2 to the power of bx as b gets larger. Okay, just like in transformations last year, it squishes the graph in. Okay, that's what's happening here. As b gets larger, it squishes the graph in. The x values would be dividing by this 5.3 each one. Okay, and as they get closer to 0, then they stretch out. Consequently, negative would flip it around to the other way, right? Like we talked about. So negative 1. All right. What about a value in front? So if you have, where are we going? If you have an a value here in front of the 2x, then that multiplies the y values each up if it's larger. So it looks like it stretches upward, right? And if a value is less than 1, then it squashes it sort of down. And then if the a value goes to negative, it flips it around the other side. So we haven't talked about this one yet so much, but if the a value in front of the graph is negative, then it flips it vertically there. Okay. This is not behaving really well here, sorry. Negative 1. Okay. So any questions about exponential functions right now as a bit of review for 8.1? Okay. All right, well let's move on to 8.2 then.